Today we are going to some problems in surface areas and volume. First sum is a test tube is made up of a cylinder and a hemisphere as shown in the figure. Here there is cylinder and there is hemispherical bottom is there. If the diameter of the hemisphere is 3.5 centimeter and the total height of the test tube it is given 17.5 centimeter, then find the curved surface area of the test tube and the quantity of the solution could be completely filled in the hemispherical part. Now here we'll write now first for the hemisphere. We have what is the diameter is given, that is 3.5 centimeter. It is always better to write in fraction. 35 by 10, you are getting 5 sevens are 5 twos are. So we can write 7 by 2 centimeter. So the radius will become 7 by 2 by 2, that is 7 by 4 centimeter. Now for the cylinder, since it is attached here, both cylindrical part and the hemispherical part, radius is the same, that is 7 by 4 centimeter. And the height of the cylindrical part, it will become from the total height, the radius of the hemispherical part, we have to subtract it, that is 17.5. From this one, we want to subtract 7 by 4, that is the radius of the hemispherical part. So we are getting 17.5 minus 1.75, so that is equal to 15.75 centimeter. Now we want the CSA of the test tube. CSA of the test tube is, that is CSA of cylinder plus CSA of hemisphere. Now we'll write the formula here. CSA of cylinder is 2 pi RH plus 2 pi R square. Now I'll substitute the values of this. 2 into 22 by 7. Radius is 7 by 4. Height is 15.75 plus 2 into 22 by 7 into 7 by 4 into 7 by 4. Now here we are going to write the common outside, that is equal to, here 2 is common, 22 by 7 is common and 7 by 4. So inside the bracket here remaining is 15.75 plus 7 by 4 will remain. So here 7 and 7 we can cancel. 2 times it goes. Here 11. So we are getting here 11 into 15.75. When we divide 7 by 4, we are getting 1.75. Add this together. 15 into 17.5. So when we multiply, we are getting 192.5 centimeters square. And this is the curved surface area of the test tube. Here there is a second part of the question. What is the quantity of the solution we can fill only in the hemispherical part, in this part? How much liquid can be filled in this? Solution can be filled in this, they are asking. That is the volume of the hemisphere we want to find out. Okay, so here now volume formula, quantity of solution is, in hemispherical part, that is volume of the hemisphere, formula is 2 by 3 pi r cube. We are getting 2 by 3 into 22 by 7. We have R is here 7 by 4. So 7 by 4 into 7 by 4 into 7 by 4. So we can cancel here 7. Here it goes 2 times. 2 will get cancelled here 11 times. Finally, when we multiply everything, numerators, that is equal to 539 divided by 48. So we will get here 11.229 centimeter cube, and according to NCERT, every answer must be correct to 2 decimal places. So 11.23 centimeter cube, and this is the volume of the solution what we can fill in the hemispherical part. We are going to the second sum now. The bottom of a right cylindrical shaped vessel made from metallic sheet is closed by a cone shaped vessel as shown in the figure. The radius of the circular base of the cylinder and the radius of the circular base of the cone are equal to 7 centimeter. If the height of the cylinder is given 20 centimeter and the height of the cone is given 3 centimeter, calculate the cost of milk to completely fill this vessel at the rate of rupees 20 per liter. Okay, here see, there is a cylindrical vessel is there. Its height is given 20 centimeter, radius is given 7 centimeter. Below this, there is a depression. It is conical shape it is. And the height of the depression, it is given 3 centimeter. And the radius is same, just like a cylinder. Now, what we want to do in this, if we fill the milk, per liter 20 rupees for milk. And we want to find the total cost of the milk here. Okay, we'll start with the sum now. First, we'll write the dimensions. For the cylinder, it is given, radius is given 7 centimeter. Height is given here 20 centimeter. Since we have two heights here, one is of cylinder, other one is of the cone, I'll take this as H1. Now, for the cone, radius is the same. It is given 7 centimeter. And height, I'll take it as H2, that is 3 centimeter. Now, the quantity of milk holds in this, that is the volume of the cylinder minus the volume of the cone. Because there is a depression here, that much milk becomes less. So here, quantity of milk is volume of cylinder minus volume of cone. Volume of cylinder formula is pi r squared, height we are taken as H1, minus volume of cone is 1 by 3 pi r squared H2, height we are taken as H2. Okay, now we'll substitute the values here. 22 by 7, radius is given 7 into 7, H is given 20, minus 1 by 3 into 22 by 7, radius is 7 into 7, height of the cone is here, it is given, it is 3 centimeter. Now we'll write common outside in this. 22 by 7 is common and 7 into 7 is common. Remaining is 120 here, minus 1 by 3 is there, into 3 will remain. So 3 and 3 will get cancelled here. 7 and 7 will get cancelled. 22 into 7, we are going to get here 154 into 20 minus 1. So we are getting, in the bracket it is, so we are getting 154 into 19. And that is equal to, here when we multiply, 154 into 19 is 2926 centimeter cube. Now since they gave the cost of milk 1 liter, they gave rupees 20 here. So we want to convert this one into liters, and 1 liter is equal to 1000 centimeter cube. So what we should do, divide this by 1000. So it will become 2.926 liters. Okay, now we want to find the cost. Therefore, the cost of milk is per liter rupees 20. So 2.926 into 20. And when we multiply here, we are getting here rupees 58.52. We are going to third sum. A hemispherical vessel of radius 14 centimeter is fully filled with sand. This sand is poured on a level ground. The heap of sand forms a cone shape of height 7 centimeter. Calculate the area of the ground occupied by the circular base of the heap of the sand. Now here, hemisphere, they gave the radius is given 14 centimeter. And the cone, height of the cone is given 7 centimeter. And the radius is not given here. I'll take this as R2. This radius I'll take it as R1. Now the question says this hemispherical vessel is having sand, and that is poured on the ground in the form of a cone. And the question is, height of the cone is given 7 centimeter. Now what is the area of the base of this? You know that area of the base is, it is a circular in shape. So we want to find the area of this. Now we'll write what is given here. For the hemisphere, I'll take it as radius is R1. It is given 14 centimeter. For the cone, radius is R2, I'll consider. It is not given. And height H is given 7 centimeter. Now here, whatever solid is, whatever sand was there, it is poured here. So both the volumes are equal. So by data, volume of cone is equal to volume of hemisphere. Now we'll write the formula here. 1 by 3 pi, radius is taken as R2 square into H is equal to here 2 by 3 pi R1 cube. Now we want to find the area of the base. So that is pi R square. Area of the circle is pi R square. That is pi R2 square we want to find out. So we'll substitute here 1 by 3. We'll keep this pi R2 square as it is. Height is given 7 is equal to 2 by 3 into 22 by 7. Radius is given 14 here. So 14 into 14 into 14. So you can cancel here 2 times. Now what we'll do here, we want to find out pi R2 square. So we'll bring this this side. Numerator 2 into 22 into 2 into 14 into 14. Then 3 will come to the numerator divided by, here 1 3 is there and this 7 will come here. Now we'll simplify, 3 and 3 will get cancelled. 7 goes 2 times here. So when we multiply all this 2 into 22 into 2 into 14 into 2, we will get 2464 centimeter square. That is the area of the base it is. Area of the base. So centimeter square is the unit. Therefore, the area of the cone occupied by the circular base of the heap is equal to, it is 2464 centimeter square.